This is a really cool section. I like. How do you know?
Judging by the presenters, obviously.
Judging by the presenters.
That's a great answer.
Yeah, judging by the presenters, this is going to be a. Did you just turn me off? Hello.
No, I'm going to hold off for now. I don't know how I'm possibly going to, but.
I'll come up and feed you bites.
Okay.
All right, we're live. This is dead. Okay, so next up, we're back from lunch, and more storage talk. Got Patrick on Twitter, Patrick_Osborne. You got an underscore in there? Wayland, what's your Twitter?
I don't have.
Oh my gosh.
So Wayland's Twitter is at HPE Converged CPI.
Okay, there you go. There you go.
That one.
And
It's easier to pronounce than Wayland.
so we back at Discover in Las Vegas started talking about something called Composable Data Fabric. Kind of as the software defined and taking software defined to the next step, and that's what these guys are going to talk about. And it's going to really ties in well with what we had this morning in terms of hyperconverged, and will tie into the synergy discussion later. So some of those conversations this morning about storage, people were asking about storage and hyperconverged and storage and synergy. This is it. So,
and one small little soundbite too. So I kind of mentioned this morning that kind of people are starting to shift across lines. So Patrick is a staunch storage guy. He probably will remain a staunch storage guy.
Staunch.
But Wayland,
He's on the right, way right.
but Wayland's making this transition, so you get to speak to you, get to listen to Rick later. But Wayland's just recently joined Rick's group, so hey, I'm really excited about that.
Yeah, and we also have product management on this side. We have engineering on this side.
Yes.
So there's a thick wall between the two of us.
Very thick wall. Should we kick it off here? Are we live?
yes.
We're live.
Awesome.
Go for it.
Yeah, so if, for contact details, if you guys want to DM me at that Twitter handle, that'd be great. I'd love to engage with all of you on topics like the Red Sox,
Yeah.
Who?
Ken Bone, whatever's trending.
Poppy.
Yeah.
Who beat the Patriots last week?
Nobody did. No, we came back. We're back on it. We beat Cleveland Browns
Yeah, but who beat them the week before?
the week before. All right, Cal. This is the last time ever.
Yeah,
I
probably.
think the last time before that was 29 years ago. But we're here to talk about the Composable Data Fabric. My name is Patrick. I'm responsible for product management within storage. So I know you guys have talked a lot about some of this stuff, these topics today. Phil covered some of our point of view on the all-flash data center.
Yep.
Sorry for the noise. And obviously we're here talking about software-defined data center. Are those things mutually exclusive? Most likely no, right? But we're starting to see some significant overlaps. These are two areas that we're really focused on for the storage portfolio, and you see it bleeding into some of the stuff we're doing in hyperconverged, because we do use some of the same IP for both stacks, and we'll get into what that means. There's other areas of storage that we focus on too, things like data protection. I'll cover how that applies to hyperconverged and some of the things we're doing around software-defined storage. So these are two areas that we're spending a lot of our R&D money. So smart people banging on keyboards every day, test rings, QA, and these are the products that we're developing on a daily basis for our HPE customers. So from a strategy standpoint, you guys have seen the wheel here more often than not for the last few years. We've been pretty consistent about our strategy. On the all-flash data center, we've been very focused from an IP perspective on 3PAR. And then you'll start to see all-flash getting into other segments of the product line too. But for our Vanguard product line out there, Phil did a good job talking to you about 3PAR and what we're doing in that space as we go from all-flash into other classes of storage class memory, NVMe and beyond. On the software data center side, our stack in that area has been stored virtual, right? So I'll get into some nitty gritty on stored virtual and what we have there in the portfolio. The key thing for this is that we're able to take these technologies and offer them in a number of different form factors, right? So I know today's focus is on hyperconverged, But we do offer these things in what we call system-defined architecture. So 3PAR is a system-defined architecture. It's a system, you buy it, you can't buy just the software, right? Store Virtual comes in a number of different formats. You can buy it as software, you can buy it as a system, right? You can actually buy it as an individual storage array, so we'll get into what that means. And then we actually put both of those technologies into our converged systems and our hyper-converged systems. So when we come out with, let's say, the CS900 for SAP HANA, right, that comes with 3PAR and blades and networking architecture. So we have systems that are put together with building blocks that are very workload specific. And obviously, I think Saeed covered this morning of what the top-down level view of hyperconverged is, and a key component of that from a storage services perspective is Store Virtual. So we do that. We're very plugged into a management ecosystem that's provided by HPE OneView and a number of other partners. Calvin asked me to talk today a little bit about OpenStack and Docker with respect to software-defined storage, so we'll cover a little bit of that as well too. So just wanted to talk for a few minutes on where we're going, this concept of a data fabric. What we're trying to provide is a set of data services and protocols and user experiences that can be manifested itself for customers across multiple different platforms, right? So here we have a couple different flavors, right? We have our Store Virtual VSA, which is what we call a virtual storage appliance. We also embed that as a product into the HPE hyperconverged appliance. So I think we spoke this morning about the HC250, the HC380, and then that experience in UX beyond, right, when we offer that on Synergy, right, and some of the pieces that we'll talk about this afternoon. So it's really a storage fabric at the end of the day that can run across all these different types of platforms you get from HPE. It also runs on standard x86 servers, and we'll get to that at the end of the day. But it's a data fabric that provides a couple of key things. This is why customers use VSA and Store Virtual, right? It's got very mature data services across all these HPE products. So we'll get into some of them. A lot of them have to do around resiliency and high availability. So there's different ways you can do replication, multi-site clustering, redundancy across different types of infrastructure and media. Proven availability, and we're well above 5 nines now, right?
Store Virtual? Yep.
Yep. So we measure that across our install base. So that install base is, I think at this point, it's well over 250,000 units in the field. So that's a lot of customers with a lot of stick time on Store Virtual. So very highly available, highly resilient platform that people base their business on. We've got customers like one of the major U.S. Package shipping companies has tens of petabytes of this in software format and appliance format that they run their business on. So it's very highly available, highly resilient architecture. It's scale out in nature, so it's a scale out service, so you can scale it up, you can scale it out. It has a number of inherent data protection techniques in it. Different things like RAID and whether you want to call it RAID or erasure encoding, we can have that debate later. But a lot of different form factors for resiliency, not only from media failures, but from system failures, from network partition failures, from data center and fault zone failures, a lot of things there. And it's a platform that we're investing in for the future for SDS. And Wayne can talk a little bit about that later, and some of the investments we're making. So a couple of the areas that we're focused on with Store Virtual are these two boxes in the middle have been sort of the bread and butter of Store Virtual and what we call the Composable Data Fabric, right? So the user experiences that people are implementing Store Virtual for, definitely around virtualization, right? So using it as a layer to aggregate capacity across shared nothing servers, right, is sort of the wheelhouse of Store Virtual VSA, mainly in Hyper-V and certainly VMware environments. So you can call this a precursor to do-it-yourself hyperconverged. So we got a number of customers doing that. And then cloud and IT as a service being the storage stack as a part of that. I don't know if you want to talk for a minute as to how Store Virtual fits into hyperconverged today as part of that cloud IT as a service stack.
Yeah. I think The way I like to think about this data center software stack, if you will, there's really kind of three layers. So at the bottom layer, there's the data path and the data services, and that provides you all of the resiliency under failure and all of the compaction services and replication and data protection capabilities. Then above that, you've got an orchestration layer that's orchestrating the infrastructure. So anytime you want to deploy new infrastructure, you want to expand your clusters. So if you're familiar with our OneView technology, that infrastructure orchestration is kind of your middle layer. And then at the top layer, you've got something that is going to do intelligent application placement, workload management, and application lifecycle management. So those are kind of your three kind of layers in this data center software stack. And today that gets solved with point solutions, right? You have a myriad of different products that go solve individually those problems. And whether that's a storage product, or whether that's a middleware, or whether that's some analytics platform, the data center is kind of a combination of a lot of these tools. So what we see as the opportunity in this data center software stack is, number one, build one solution that has a single pane of glass for exposing all of those services. And number two, to be able to have that software stack run across the portfolio of platforms. So let's take the hyper-converged, quote unquote hyper-converged or hyperscale products as an example. A lot of them are very focused on delivering something that looks like an appliance, that's very specific to a given platform, that maybe is locked to specific hardware, that does a certain thing. And they're trying to solve a lot of these problems of building out enterprise services by basically inventing that whole stack. Where we see our advantage at HPE and enterprise is that we're taking things that are enterprise class stacks. So let's take the storage layer, store virtual. This is an enterprise class storage stack. It's hundreds of thousands of instances in deployment, in production. We have all of the data services you expect from a real enterprise storage layer. That's a difficult thing to replicate, and a difficult thing to go, come to market with that has the maturity of a storage data path. So that's an advantage. You take a look at another capability we're leveraging, our file system capability. So we have a unified product on 3PAR called File Persona. It's built on our adaptive file system. And the genealogy behind that file system is a file system you may have heard called ADVFS, which is the old DEC True 64 file system. And that's a file system that has hundreds of man-years of development and robustness and capabilities. And that file system technology ships in our enterprise products, but is also core to this composable data fabric. So really, you have to break the layers of this stack into the kind of those, unique elements. And really, I think where we bring a lot of value is that enterprise capability that can be platform independent. And there really aren't a lot of other players out there. Turn it off?
Yeah. No, not yours. It's
Getting the sound guy.
Is that better?
Come and see if we can fix it.
Yeah. Go ahead and turn them off. I can still get you guys.
Okay, all right.
There's a weird, or you're hearing it too, feedback.
Oh, I thought that was like a train or something.
No.
I thought that was like a monorail.
It's us.
So as long as you stay by those microphones
Sure.
that are on the table,
Yep.
Okay.
you should be
They
fine.
can hear
Okay.
us. Okay. So we can dig into kind of what the technology looks like underneath, but really think about those three problems that you're trying to solve in this data center stack, and why we think we're uniquely positioned to be able to take advantage of the data center stack. It's a lot of enterprise IP that has to come into play, and really it's the orchestration around a single user experience, because you've got customers who have robo use cases, but they're enterprise customers, right? So they need both the enterprise services, it needs to fit into their compliance models, it needs to fit into all their processes, but they also need something that maybe is in remote offices and manufacturing sites and remote locations, and they need that simplicity around a single pane of glass, a single user experience that an IT generalist can manage this complex infrastructure. So that's really kind of the game that you got to solve when you're talking about this data center software stack.
So the two areas that we've been focused on in the middle here, right? Virtualization shared storage, and some of the stuff that Wayland just talked about in the context of hyperconverged. Where we're looking to bring some value to our customers in the future, actually some of this in the near term, on the right, containers, right? So you guys have seen a requirement for persistent storage for containers. There's a number of different options for that. I'll talk through some of them. But we want to be able to provide that type of that file system layer and the block layer and just general persistent storage for a number of different use cases. Many of them around failing over HA, persistent storage for databases, different things that you want to see in the world of containers. On the unstructured data side, a lot of these focus areas have been around providing a block layer underneath VMFS, right? So you're providing a scalable VMFS solution for multiple for VMware, and then also for the equivalent on Hyper-V. Getting more into unstructured data workloads in this area, especially around file systems, and then we do have some other things we provide within the portfolio around object storage as well too, is something that we've been pretty focused on in the last 2 years. So just kind of hammer ahead here. We have a number of experiences we provide. We talked about do-it-yourself on ProLiant, embedded in hyperconverged, and then as you start to see this stack become available at scale, at rack scale and data center row scale on Synergy. This is where you'll see the data fabric, really start to kick in. It's basically a layer of highly available shared storage on server platforms on demand, right? So you can do all this stuff within one view. You don't have to go into be a CLI ninja or anything in the UI specifically. Basically, storage becomes an invisible layer from the orchestration perspective. And then you have a number of different tiers, capacity, performance tiers. And then one of the key areas is around data mobility. So data mobility between different types of primary storage, and then data mobility between secondary storage. And I'll get into a little bit about what that means. We want to be able to work together with other architectures, in the data center. So in the case of data mobility, making sure that you can federate your software defined with system defined, right? So if I want a workload that I feel should be promoted from hyperconverged over to a 3-tiered system, like 3PAR and servers, right? You could be able to do that experience. If I want to be able to federate something with a secondary system, like Store Once. Who's familiar with Store Once? You've heard of it? Yeah. So deduplicating secondary storage. You can move that workload onto secondary storage for the purposes of backing it up, right?
You were in the room when I had my training,
What's that?
when I got my Store Once training.
Yeah.
You were training people, Patrick?
No.
No, that's scary.
That's scary.
That's just a requirement, just personal proximity. So one of the areas, so we've been a leader in this space for a while. If you take a look at what we're doing around SDS and store and the virtualized environments for Store Virtual, we've got over 20,000 customers running Store Virtual VSA in a sort of, I guess you call it like a do-it-yourself or hyperconverged experience, right? So these are customers that are taking Store virtual storage appliance, running them, co-locating them with a hypervisor and applications, and using it to aggregate capacity across multiple servers. So that is at least 2x times what our main competitors are that we see in the market, which are essentially vSAN and Nutanix. So with the ability, and that is just a fraction of the number of systems we have in the field, because you keep in mind, we also provide Store Virtual in appliance format, right? So we, I don't know if you guys got briefed on the SV3200, the Store Virtual 3200. Have you seen that yet? So it's a entry storage system based on ARM processors, right? So it's very low cost of goods, so we can provide a very valuable price point to our customers for entry storage in an array platform. Same software, right? And so we've got tons of units in the field. So we've been able to take these multiple experiences and drive that. And as a derivative, we have a number of customers that use VSA for this specific thing. And then when you take a look at the hyperconverged platform like HC250 and HC380, that is an appliancization of that experience. I don't know if that's an actual verb, but I'm going to use it. you're providing a very easy install experience, deployment experience of less than 15 minutes. Whereas Store Virtual VSA takes some work, right? You got to spend some mental capital and some cycles to get that up and running. There's a lot of customers who choose to do that, but so just a lot of installs in the field. So we feel like we want to people don't know this stat about our technology, and we're very proud of it in terms of the number of customers deployed. So from a vision standpoint, one of the areas that we definitely want to focus on with the platform is we want to make all these things work together, right? From a storage and data layer. So when we say a composable data fabric, right? It's not just about providing services across server shared nothing architectures. We want to make that ubiquitous with other data, the other data sources in the data center from HPE. So a couple of things that you'll see throughout the year is federating Store Virtual and 3PAR, right, for workloads, right? Being able to either use it as a replication target, bidirectional replication. Some people want to have like a core edge type of implementation, or you want to just have a very low cost DR target. Actual peer motion of workloads, so moving one workload from let's say hyper-converged or SDS to 3PAR, which is that's a high ask from our customer base. And then also when you bring in secondary storage into the mix, I'll talk a little bit later about what RMC is and what that means. So a lot of things we're doing here in the platform that we think are going to differentiate the system from our competitors. So I don't know if you want to talk about one interface feature set and some of the things you guys are working on from a user experience and moving into synergy.
Yeah. So what we so there's two products that we ship today: the HC250 and the HC380. The HC380 is our hyper-converged, kind of flagship hyper-converged product. It has the Store Virtual technology as the foundation for the storage layer, but we built a management framework around OneView that gives the administrator an experience, a kind of a cloud-like experience for managing VMs. So, similar to how you'd interact with a Glance repository, for example, in OpenStack, you can have templates for VMs, and you can provision those VMs and assign them across your infrastructure. And we have future products that continue to innovate in that space, where we integrate other software products that do more on the analytics side, that will look at the how your infrastructure is being used from a performance perspective, from a CPU utilization, from an I/O workload, and more intelligently decide how to place your applications and your VMs across your infrastructure. So the hyper-converged experience again, is kind of two dimensions. One is the operational aspect of it, which is how does the administrator interact with that infrastructure? How do I expand it? How do I manage capacity? How do I manage performance and alerting, monitoring? Then there's the kind of the everyday admin experience of provisioning application VMs and how to manage those life cycles and how to easily provide that service for the customer, because everybody wants that cloud-like experience, but a lot of these enterprise IT customers don't trust moving their actual workloads to the cloud. So they want something that's easy to use and easy to deploy and easy to manage. So you can imagine a lot of these products getting deployed in small offices and in remote sites. So simplicity is really kind of the key. So the HC380 is the product we're shipping today, and we have kind of a next generation product that builds out this platform. I don't know, Saeed kind of talked a little bit earlier about that roadmap for hyper-converged products, but think about, I talked about that 3-tier stack up of the data center software. At that kind of workload management layer, the way we kind of think about that layer is it's a platform that we can build an ecosystem around. So we don't envision HPE being the provider of all applications that you would ever want to integrate on top of that infrastructure. What we kind of see as the opportunity is the infrastructure as code, as providing the rich set of APIs to be able to orchestrate all of that infrastructure. And over time, what we want to do is provide a ecosystem for application vendors to come in and take advantage of that platform and be able to integrate on top of that platform. So provide the APIs, provide the integrations and kind of the user experience, but have pluggable engines that can go on top of that infrastructure. And that's kind of that vision of platform as a service from an infrastructure viewpoint rather than an application viewpoint that I think is kind of unique.
We've actually covered some of this here.
When you talk about over time, long term, short term, what's the vision of that?
It's actively being worked. It's my R&D team is the team responsible for that whole product line. So we're actively working on that, and I think you'll see some announcements, pretty soon around this space and what we're doing, kind of from a vision perspective, and then concrete products as well.
It's not 5 years out.
Yeah, it's not 5 years out.
It's tricky trying to figure out the nomenclature for that infrastructure as a service, platform as a service. It's hard because it's more advanced than the traditional infrastructure as a service, but it's infrastructure.
Exactly.
Yeah.
Yeah.
Platform as a service has its own weird hole.
Right.
Yeah.
Yeah. So it's not application platform as a service. It's not trying to be an app engine or anything.
Yeah. Good luck. I mean, not saying this facetiously or weirdly. Just good luck with that. Yeah.
Yeah.
But in fact, please come up with some good terms so that we can.
That's why we pay him the big bucks.
Hey, Patrick, there you go. Cha-ching.
Yeah. Sorry, I'm here hanging out with you guys. The taxonomy is obviously a challenge, right? At the end of the day, so that becomes just that's some naming jujitsu, right? I kind of wanted to get a little bit past some of the vision stuff. As you can see, we're really trying to take this composable data fabric, and it's a great platform, right? We've been investing in it and continue to invest in it, and dollars and engineering time frame, and we've got a ton of customers who use this as their mission critical storage platform. So as you can see, it's already woven into a number of our different offerings. So if you take a look at from the right to left, we have the data fabric as Store Virtual as part of dedicated storage arrays. So we just came to market with what we call the SV3200. So this is the entry array that I talked about. That's ARM based. It has a number of different media options: small form factor, large form factor drive. It has flash. It has a starting price point, I think at like 5 or 6K, and then you'll start to see some announcements around that later on this year around some additional features and functionality that match what we're doing in software in terms of things like scale out and all sorts of different protocols and things of that nature. So we're able to take that software stack and bring it down to the entry, right, where you saw the trend last year was take a lot of the high-end features and functionality and bring it down to the mid-range. Phil talked a little bit about that with Flash and how that's collapsing the high-end market. We're doing the same with the entry storage as well. Obviously, it's embedded in the hyper-converged appliance that we see before. We have some other areas that we deal with as HPE. It's an integrated stack within Helion, right? So we have a number of OpenStack distributions, and we have a partnership now with SUSE as well too, where we actually provide VSA as a component of that. So if you license that stack, you get licenses for the storage layer as well too, right? So the whole thing comes together. You get OpenStack, you get a number of different things on the orchestration side. You get a full-fledged storage layer that comes with that as too, right?
Can you say that again? Okay.
What's that?
Can you say again the SUSE? What you were doing with
we have
SUSE
you see like that. We are. I'm sure you guys saw the news around the HPE software spin merge, right?
Yep.
Do you see, which is a new term I guess we came up with, spin merge, spin merge, and so the SUSE, stack, they have their own OpenStack distribution. So today our Helion stack, right, which is what we distribute as part of Helion, that includes Store Virtual VSA licenses, right?
so SUSE will give it to you.
So today, so if you buy Helion OpenStack distribution today, you get Store Virtual with that as part of the whole licensing mechanism. So
just the licensing, not the appliance, or it's not sitting on a converter.
It's software defined.
It's software, yeah. It's part of that stack, right? And and it's plugged into OpenStack and talk about how it's got Cinder drivers and way to automatically distribute the VSAs as part of the Glance, repository and things like that. So that's part of that. And then NFV is becoming, it's a small market right now, pretty focused on the telco, market. They're essentially what they're doing is they're taking ruggedized or specific, hardware equipment that they've had in Knox and all the networking sites, and that's very swiftly moving towards software. So VSA is part of that reference architecture as well. So we're not only just embedding it in servers, Synergy, and some of the appliances, but it's going into full, IT stacks that become a little bit more specialized for the consumer. So it's there's been a lot of cool stuff we've been doing with VSA moving forward. So we talked a little bit about the enterprise nature of it. It's been in the market for 9 years. We've got very robust data services and experiences from customers. Over 20,000 installations of VSA, paid, running, and production installations. This isn't just give out a 1 terabyte free license. This is real stuff. The things that people gravitate towards for Store Virtual is around the enterprise feature sets. So a number of these things here, obviously scale out is primary. We've got a lot of other things in here that people are they use it and they base their services around, especially around the high availability. So if you take a look at if you kind of put these in buckets, it's very simple to manage, right? So you get a centralized storage management, nice UI. It also has a full API set that we publish as well too. So almost all the operations you can do are scriptable through web services APIs. It's hypervisor and hardware agnostic, right? So you can run this thing as part of KVM, as part of Hyper-V and VMware. And then we also have a number of plugins for OpenStack and Docker, right? So I can get into some specifics there. In the other buckets, scalable, right? So you've got linear scaling and performance and capacity. We have customers that run these in appliances with hundreds of nodes. I mean, some really, really big installations. And then when we talk about scale, being able to do peer motion of workloads between different types of arrays. So that's pretty cool. I'd say that one of the biggest areas is around high availability and protection. Those are the areas that the technology really excels in terms of HA, multi-site resiliency. These are the things that software-defined stacks in the market don't do, right? So you're not seeing this type of architecture from vSAN or other folks where you can have multiple fault zones and multiple different DR configurations with your iSCSI and LUN services all online. So it's pretty cool. I have some specifics if everyone wants to get into what those are, but you see things like you can start very small. 2-node quorums, right? So you can start up a 2-node system and scale that out very far. We provide things around network RAID, so RAID 0, RAID 1, RAID 5, different types of topologies. And then, we can talk about multi-site and stretch clusters and things like snapshots. It's a very full-featured data stack.
I don't think anybody out there has this one technology stack that we deployed as software-defined and system-defined. So having the ability to scale out and have a hybrid cluster and be able to have some of your capacity managed purely software-defined and some of it as let's say purpose-built entry storage from a system-defined perspective. I don't think anybody else is doing that, has that ability.
Is Data Fabric built in? Is it software that is built on top of and into both storage stacks, or is it a separate?
It is the storage stack essentially. Yeah. So in the hyperconverged space, it's a virtual machine that is providing storage services. So it basically is taking ownership of the physical capacity and then creating a cluster across all of the instances of that composable data fabric, and then providing those storage services as a common pool of capacity. And both, unstructured data and structured data. So, providing kind of your traditional NAS, NFS and SMB, and also, iSCSI storage. And that's all out of a common single elastic pool of capacity. So one of the things, when you kind of break up the taxonomy of what storage problems you have to solve in these hyperconverged systems, there's the Nutanixes and vSANs of the world. They're providing capacity for the virtual machines themselves, right? So, it's the file shares or the block volumes that you're storing your VMDKs and your VMXs and all that stuff. And with that, there's a certain demand of the storage, both from a performance perspective and a capability perspective, that's restricted, because you're only attaching to certain kinds of hosts, they being, virtual machine hosts, right? But there's another class of storage that you want to share out of that same pool, that's your application storage. So you're running VMs, you want to be able to mount something that looks like Amazon EFS or Amazon EBS, right? So it's a persistent store that attaches to that volume, and or attaches to that instance. That instance may want to store data that's independent of the life cycle of that VM. It may want to have raw block access because it's running a database or Exchange. And this is where the rubber meets the road, because a lot of the early stage companies that are building storage stacks solve the former problem, but not the latter problem. So the latter problem is a hard storage problem to solve, because you're building real storage, right? Like, let's take NAS, for example. It's one thing to expose an NFS v3 share to a VMware host. It's another thing to actually expose, a file share that's common across Windows and Linux and supports all the cross-protocol semantics you expect, and it's got file access auditing and worm and retention and antivirus and all the things that you expect from storage. So this is where a company like HPE that has a rich tradition and technology around storage, because all of these software-defined systems start with storage, because storage is kind of the fundamental problem you got to go solve. And I think that's why we think we're uniquely positioned to be successful in this space.
So, did I understand what you just said? That all software-defined systems, all software-defined starts with storage?
I like to think about it as that's the foundation, because the first thing that you have to do with software-defined is aggregate all of the capacity in a way that can be shared out as a single kind of logical pool and protected. So, think about what's the difference between a system-defined system and a software-defined system. The system-defined system is it's an x86 CPU, but it's got some custom hardware that's giving you shared backplane and access to kind of those physical disks, right? And whether they're JBODs, there's some physical infrastructure that's custom built for that. Whereas a off-the-shelf server is just one CPU and direct attached storage. But that is a single point of failure. So the first thing you have to do in any of these software-defined systems is provide a persistence layer that has resiliency, that can survive any point of failure. And that is essentially building a storage stack. I mean, that's what a storage stack does, right? It just does it in such a way that oftentimes 3-PAR arrays and EMC arrays are built on some custom hardware. So software-defined, the first problem you got to solve is how do you provide resiliency in the face of basically single points of failure, and that software is basically your storage stack. That make sense?
No. But I heard what you said.
Okay. Happy to.
Yeah, why doesn't it make sense?
It's because, well, first off, it's somewhat of a contrary view of software-defined, but the other thing is that the whole point behind software-defined is really to allow the application to drive the process. So understanding how the application needs to consume resources and then drilling into those particular resources.
Absolutely.
Not the other way around.
Yeah, and maybe starts with storage is a very storage-centric view of things. And I think that you're talking about there's the resiliency layer, survival under failure. Then there's the optimization layer, which is how do I make my workloads run closest to the data? Kind of a similar, MapReduce kind of paradigm, right? Where you want to make sure your workloads are running as efficiently as possible, and to run them as efficiently as possible, you either move the data to the app or you move the app to the data, right? So there are two different problems. There's the problem of how do you survive under failure, and software-defined means you're running on commodity hardware that doesn't give you any inherent ability in the hardware to be able to protect that data. So the storage layer is giving you that resiliency layer, but it's not solving the workload management layer. So that absolutely is the right way to think about, kind of division of labor there. They're both storage related, but they're different aspects of the storage.
Okay. Yeah, I think you guys are both on the same page. I mean, if you said that you're talking about it from a configuration standpoint, just to make it available, then that's one thing. But if you're saying that the way you define it is by starting at the infrastructure, whether it's storage or system, and working up, I wouldn't agree with that. Because I think that driver has to be from the application, and the application is what matters, not the infrastructure, candidly.
Yeah.
Right?
Yeah.
It shouldn't matter.
Yeah.
I understand the business that you're in, I respect that, but we're in a different era now, where it's the application, it's the developer that drives the conversation, not the infrastructure admin.
Yeah.
And that's one of the views of, so if you take a look at this composable data fabric, the fact that we're providing it in a bunch of different form factors is driven by the application consumption, right? There's some customers are going to want to use for a certain set of apps, 3-tiered architecture, right? They're going to want to use servers, networking, and storage, right? So you have that store virtual array, networking, iSCSI, different types of servers, right? There's going to be customers for certain workloads that it's very simple. It needs to be spun up, spun down very quickly. Paul will talk about this later, that you want to put on hyperconverged, right? There's going to be people that want to, have, so that workload is going to drive the different form factors that we make available, and you can choose which one's appropriate for the application, depending on what you need.
If I may, since it's software defined, so kind of the way we've drawn this up in the past.
Cool design, by the way.
This is,
Sorry.
hey guys, I know I've. So essentially you have your app up here, you have your infrastructure down here, right? And I think this is what you're essentially saying. The goal is to get the app down here. In order to get the app down there, you have to get the infrastructure ready for the app, right? Because the app has to sit where it wants to sit and how it sits. So you need to have a set of intelligence to drive that app down to the infrastructure, define the infrastructure. But you also have to you want the infrastructure to have the ability to create that home for the application, or that footprint for the application, right? So I think what we're talking about here is how do we go and make sure our infrastructure is software defined and can conform to give the application the footprint it needs. And if that application footprint needs to expand or contract, it has the ability to do that, right? So the intelligence, the policy comes from the application that's driven down here. But if your infrastructure can't react to that intelligence and policy, then there's no use because that application will never get where it needs to go.
See, I don't agree. I think that switching to one side of the compute might crash the application. So I agree with the part, I don't agree with the part that, before you talk, I agree with the part that when you have your application and you want to approach the application to your information, but you need computing power to do that. So the SDN is not going to give you that advantage. So putting everything on one side just to reach the information, won't that risk the computing power for the appliance?
So I think what I'm saying here is typically your application is going to define what it needs. Right, in the ideal software-defined world, you're going to put a set of policy around that application that says what infrastructure that application needs. That policy has to be executed somewhere, namely at the infrastructure level. That policy has to go and create that footprint for the application.
They're always going to come out policies, and it's going to be the main thing. Every time you want to move one thing to another place, policies are going to come up, things are going to, emerge. So you should, before you do all this stuff, you should design your architecture the way you want it.
Absolutely, I totally agree with that.
So you don't have to go through all this. From the beginning, you can do everything and design the application. It may take you a long time. I'm not talking about 3 days here. I'm talking about a long time.
I think what we're saying is if you have an application that needs 125 gigs of disk, you ought to be able to go and serve up that 120 gigs of disk. And so down here, you're going to have a set of software-defined intelligence that is going to go and give that application the 120 gigs of disk, and this is what you're talking about. So here you need a set of intelligence to give the application what it needs, but up here the application is actually going to be driving the request to get that. if it asks for it and this infrastructure can't give it, then you're broken. Right? I think that's fundamentally what we're trying to. Sorry, guys, not to.
Yeah, no,
I
no.
think this is going to be an important topic as we go to the end.
Yeah. We do an hour with Gary Ample, and then we do another 30 minutes with.
Yeah, and it's essentially at the storage layer, what we're trying to provide is a set of infrastructure that's flexible enough to fit into a nominal number of, I guess you'd say, like green boxes, right? If you have something that's super highly available, very latency intolerant, right, and needs, you know, very high performance, right? What can you do from a storage layer to provide that, right? If it's bulk storage, it's super cheap, it's write once, read maybe never, right? What are some classes of storage that you can provide to give that experience, right? And then there's a whole bunch of stuff that's in between, right?
But the thing is, like, you start from B blocking, moving into it. Before you start doing the storage, you should start migrating with B blocking, what we call B blocking. I don't know if you're familiar with virtualization of blocking, blocks for infrastructure. So the way that it is right now, when you want to start doing your movement, because you're coming from, you have to understand, you're coming from silo. This is a different client. I'm not talking about the client that just landed on Converged infrastructure. I'm talking about the client that came from the silo to the Converged to the hyper Converged.
Sure.
And now he figured it out. He just figured out what Converged infrastructure means. So the way that these automatizations are going to help you develop, launching these B blockings of the infrastructure one at a time. Don't you think that would be better to centralize the storage than to assign the storage by B blocking?
It depends. I mean, I've seen customers do both. I mean, if you got a customer that is like, I can think of a number of customers who basically are software providers, right? And then they're moving towards taking their software and providing it as SaaS, right? So now they're building a cloud. And now that they're building a cloud, what they're doing is they're making what they call, maybe your term V-blocks, right? But they're calling them pods, right?
Pods.
Which are, you know, basically building blocks of infrastructure that provide a well-known, you know, experience that is like big enough that they can manage it, right? It's not too big, right, from a fault zone and, you know, architecture perspective, and they can repeat them over and over. And they have different kinds, you know, like a small, medium, and large, but that's where their basic unit of architecture lies, right? And so, I guess one of the things we're trying to say is that you can use this technology; it's flexible enough to provide a small, a medium, and large, depending on the way you deploy it, right? And then you can land, obviously, applications or customers on that type of infrastructure from a storage perspective.
And you should have on the small, like, many other options.
Yeah, there's a lot of options. There's too many options, probably.
Patrick, you got 10 minutes.
10 minutes, okay. So Calvin, you wanted us to cover a couple things on RMC and Docker, and right, so should we jump into that?
How many people know what RMC is? What would you think, RMC or Docker? RMC, what Docker?
I can cover RMC just real quick and then move over to Docker, if that helps.
Yeah.
Wait, hold on, let me try to find this. Docker is sexy. Hold on. Too much animation. What just happened?
That's sexy.
You want to go into the agenda.
Sorry.
Jump decks.
Oh, I got it here.
Can you call a fabric that is on 3-part, not on synergy? Can you still call it a fabric? Can you?
I'm good.
Can we call it fabric?
Is that good?
Yeah.
Why can't we call it fabric?
I don't know. Just always I see fabric, I see synergy on it.
Well, you're getting networking, you're getting storage. To me, it's
still storage.
Okay.
On steroids.
I think that the difference is that we think about storage as being in these blocks assigned to something, and now storage fabric is now across everything, just like networking. it's data center fabric. That's what we're going to do. And I think, I don't know, I want to preempt these guys, but what I see really exciting about this is that as you've got networking fabric in your infrastructure, across your infrastructure, now you're going to get storage fabric to where it's moving data automatically based on your need, based on the application need, based on cost and availability. So I think it's more than storage. I think it's actually now a storage fabric that's wrapped across everything. And it goes into very much what Gary and Paul will be talking about with composable infrastructure. Talk about fluid pools.
Yeah, I think at the end of the day, it's more about, you know, intelligent placement of data, right? Try to cut down on data movement at the end of the day, right? There's some of the stuff that you never are going to be able to avoid, things like multi-site and clustering and, for example, data protection where you have to
You're
move
moving
bits.
data, though,
Yeah.
Patrick, based on cost. And it's not going to be all storage is equal. So I'm thinking.
Sure, there's a life cycle to it. A lot of data has its own gravity, right? You know, per se. So one of the things we're trying to do to ease some of that data movement, right? Because moving data is costly, right? You know, from a bandwidth perspective, is we have this technology called Recovery Manager Central. So one of the things that we're able to provide is a very high performance integrated experience for this composable data fabric for Store Virtual that will allow you to take application consistent snapshots within a VM and then be able to take those deltas. You can either replicate them to another like fabric, right? You can take snaps and you can actually back them up, right, to a secondary storage unit, for example. You can lifecycle those snapshots. You can run workloads off the secondary storage, right? So there's some pretty cool things you can do with RMC, and there's some good integration points with, you know, various types of applications. I have SQL Server and VMware. We actually offer Oracle now. We have Crash Consistent for other applications. We're going to be coming out with SAP HANA later on this year. So some pretty cool technology. Yeah.
Do you think this is the first step for offering storage as a service? I mean, we have platform as a service. We have.
You have what as a service?
We have platform as a service.
Yep.
We have compute as a service. Now, do you think this is a first step for going with storage as a service?
So we have customers that use these basic building blocks, so Store Virtual, RMC, and other components to provide storage as a service, right? This alone is not going to provide you storage as a service, right? So you have to have, what Paul will talk about later too is what some of our customers use, is a higher level automation service that has to come with this, right? So at a simplest format, you know, for example, we have a number of service providers that use 3PAR, Store Virtual, Store Once, and RMC to provide a storage class, right? So they chunk it up to platinum, gold, silver, and bronze, right? All of them have different, you know, capabilities in terms of IOPS and latency. How many, you know, recover points are you going to provide over how long of a, you know, time vector? Different types of failover and, you know, replication capabilities. But really, at the end of the day, what you're doing is you're taking all that and encapsulating it into an automated service, and then you have to figure out a way to amortize that and bill it, right? So there's a number of different things that we provide. For example, on Store Virtual, we're going to provide, we have it in pilot with some customers right now, pay by the drink, you know, licensing. So your per gigabyte per month that a service provider can license Store Virtual, right, from HPE. So they don't have to buy all their infrastructure up front from a storage perspective, and they can use whatever server technology they want, for example. So these are basic building blocks that people do use to build storage as a service, no doubt. Absolutely.
You just gave me a business idea.
We get charged for it.
Well, we have partners that are doing this, right? I can give you some references, like folks like 99X, DSM, CenturyLink, Savvis. I mean, we've got, like, you know, a lot of people use these technologies as part of a storage as a service offering. All right, so
You got 2 minutes. Sorry to keep.
Yeah, sure. So, we talked about OpenStack. I mean, we've got a number of integrations I talked about a little bit before in terms of Helion and a number of the drivers that we provide for Store Virtual. So we've got, folks that use VSA as a scalable storage service within an OpenStack environment, right? There's other services that come along with that, networking. You can obviously do Swift for object storage, but for people that need consistent storage that has a certain latency and availability envelope, totally plugs in. You can definitely get there pretty quick. It's bundled, blah, blah, blah. So for some of the things we're doing around Docker, what's that?
Can you talk about trends around customers that are the last two slides? So
In 2 minutes.
has there been any significant uptick or change in the trajectory of customers that are gravitating toward these solutions around Helion OpenStack?
With respect to Store Virtual or just Helion OpenStack in general? I don't have an answer for you on that.
What about within storage specifically?
So we have a number of storages. So we track basically people that install 3PAR and Store Virtual. We have Call Home, like who are using within an OpenStack environment, and it's going up every quarter. I mean, so people are downloading all of our drivers, plugging this stuff into automation frameworks driven by OpenStack.
Is the trajectory changing? That's different than.
Oh, so you're talking about if it's a non-linear trajectory in terms of adoption. I don't know. I can find out. I can definitely get some of the stats. I just haven't looked at it for the last quarter.
Is the Store One capability, does it have the capability as a catalyst for backup? Like from site to site?
Yes.
There you go. That's right.
So
Solid. Yeah.
And it's not reliant on, it's storage agnostic kind of target.
Yeah, you work for the 3PAR. It makes us a
And
copy.
it also integrates with other backup software products. It just provides the centralized management layer. It's really very flexible and very cool.
Yeah. He was through.
Yeah, just want to get to this last piece on Docker. So we have some different experiences we support through Cluster HQ and Docker, as well as the VMware container implementation. There's a couple of use cases that we've been customers have been asking for is basically migrating some of the databases and its persistent storage. Stateful application failover. If you want to save state, for an app that's not going to be stateless, and then accelerating some of the recovery time of some of these distributed NoSQL databases that people are proliferating with Docker. And the way you can do that is through providing stateful storage. So we have plugins for both 3PAR as well as for Store Virtual to provide stateful container storage. I don't know if you want to talk, if you have any insight into some of the stuff we're doing on the file system side. I mean, there are file system services for Docker that are not
we actually did a
persistent.
demo at June Discover that had our file system technology. So I was talking about the file system being a clustered file system. So you can have a node that's running Docker containers, but that same file system namespace can be available and consistent across the entire cluster. So one thing around these kind of stateful containers, if you will, the use case would be, I've got, let's say, a web server running in a container. The normal way of doing that would be to just, destroy that container and start it up on another node, and it has to start fresh. But there's use cases for that container coming up with the same state it had before. So whether it's the, cache files or, configuration or whatever. So having a file system, because the container namespace is provided through a file system. If you've got a clustered file system, if you've got a file system that can provide that unified namespace across your entire Docker cluster, you can enable this use case of stateful containers. And we actually demoed that at Discover with our clustered file system as basically an alternative file system to AUFS and OverlayFS and ButterFS, the normal siloed file systems that you usually deploy with Docker, but this was a clustered file system, which is our adaptive file system.
Which is Cluster HQ?
Cluster HQ, think about that. That's the manageability layer.
Piece of it, yeah.
We
This is
provide
separate
yeah.
part of it. think about it as a fabric that is going to provide you persistent storage
Right.
across disparate nodes in a Docker implementation. Yep. So you can have state saved when you want to move stuff in between or even shared storage, right? So you've got the file system portion of it, and then you have something like this, which is, more of an implementation you have with arrays externally or software defined running on the same nodes.
Yeah, think about the files, the clustered file system is enabling the software-defined shared storage for containers. You can have that same paradigm with an external storage device, but it basically means that you've got a system-defined solution that's network attached versus being able to utilize the capacity that's already there within your host that's running the containers.
So yeah, I think we're out of time. If anybody wants to ask any other questions around storage, or you want to dig into some of the RMC stuff later, I'll be around. Wayland will be around for this afternoon, definitely. So
Both coming to dinner?
I'll be at dinner.
Plan. Yeah.
You do?
Yeah.
Thanks very much.
Great.
Thank you.
Thanks, guys.